Okay, I think I'll get started, and then by the time Alex gets with this session, get started with the session, I'm sure that more people will have joined. So welcome to this new Dev Talk. This is our 34th Dev Talk. Today, we are really pleased to work with Alex Lawrence from Sysdig. We actually, if you followed the hack track during Discover, we already worked with Alex for one session, and we are happy to give him more time to discuss some of the solutions that Sysdig brings to Ezmeral. So let's get started with just a couple of items I want to cover. As usual, as I said, we started this program last year, January, every 2 weeks. We have a calendar of events on our DevTalks webpage, so keep an eye on that. You find the calendar, but also all the registration links for the upcoming sessions and the replay links for the past sessions. I was almost going to confirm some session for the next round, but I don't have a full confirmation yet. So stay tuned for what's coming up in September, but we'll continue that program in next months. We need you for the community to grow, and this is a call that I'm making every 2 weeks. But we have provided a new service, or not so new because we started it last year, but called Workshop on Demand, which we keep on enhancing by adding new workshop. We have today 20 workshops that are available on the HPE, the hpdev.io workshops. So take a look there. We cover a fair amount of products, and you can get your hands on through an interesting Jupyter Notebook experience. So it's a nice way to get your hands dirty in a kind of a guided way. And please take a look at those workshops. They are on internet. They are available to anyone. And feel free to provide feedback. We have a survey that we ask you to complete after the workshop is finished. So as an HPE employee, we're really happy if you could provide some feedback so we can improve, grow, if grow, in which direction you'd like to see this go, so you can use it with your customer or with your partners. You can also contribute to the HPE Dev program or the HPE Dev community by discussing with us on Slack. We have now a channel on the internal Slack that HPE IT has brought for us. It's called Ask HPE Dev Community. We also have our own Slack channel workspace in which we have topics for each of the platforms that we support within HPE and HPE Dev. So feel free to join and voice ask questions, answer questions. This is meant to be used by all of you. We also are desperately looking for contributors for blogs. I am sure you're working on exciting stuff, on exciting technology. We can help you to bring kind of a draft of something you'd like to publish to a full blog on our website. We control entirely the process for this. So we are talking here about a couple of weeks before you can get your blogs up on HPE Dev on the internet. So think about it. It could be a customer experience, anything that is interesting for other developer, we could do. And we are looking for blogs on any kind of topics that we have a platform for, and also for open source technology. So it's quite wide as a spectrum. We are also looking for speakers for Dev Talks, such as this one. So if you have something you'd like to share with us, technology, a project, something you learned that you want to share, please speak up. Remember, these are internal talks, and we are easygoing. You can get a slot pretty easily in the calendar, so don't be shy. We have a Munch and Learn going on also next week. And as you know, or maybe you don't know, but Munch and Learn is a different type of program that we started last year. We started this year in January. So this is only the 8th one. And it's a monthly program. And this is more like trying to get very higher level vendor agnostic kind of education talks with industry experts that can share some of the insight about Kubernetes, for example, in this case, This one will be a little bit different than the other Munch and Learn because there will be a hands-on part to it. So this is a session that we offered in Discover, and we are doing one more for our Munch and Learn audience. So next week, same time, more or less, you can also learn about other Munch and Learn that we're doing, or the ones that we recorded so far on our Munch and Learn page in the website. Please also, when you can and when you deliver sessions to your customer, don't forget to mention the fact that we have a developer community. We have one slide that we'll be updating and posting on the internal Slack that you can use to leave behind in your slide deck. That just gives the pointer to our website. And with that, customer would be able to find out about the multiple channels that we offer for them to join the community. That's it for me. And with that, I'd like to introduce Alex. And this is the slide I was talking about that we will make available. Alex, I'm done, so it's all yours. Thanks.
Yeah, thanks so much. Yep. So thanks for having me here today. Really appreciate the time you guys are all giving us. Main thing I wanted to talk about today is just about Kubernetes and container security and observability and kind of the world that brings our kind of joint customer base out there. So if you have questions, feel free to throw them in chat. I'll do my best to monitor and answer as time permits. But the goal here today is to kind of just go through that cloud native approach, see how our customers are leveraging containers in Kubernetes and making sure that everybody's familiar with those pain points and the experience those customers have in this kind of cloud native stack. We'll also do a demo of how Sysdig approaches solving some of these problems. And hopefully there might be some stuff there that you think is interesting and you want to check it out further. So with that said, really what people are doing here is building this kind of modern cloud application stack. So they have the compute layer, and their compute layer is really getting abstract, right? It's containerized, it's either Kubernetes, it might be some raw instances, it might be services like EKS or AKS or any number of things, right? And ultimately what's happening is the compute layer is getting abstracted away. And that's wonderful for portability, not so wonderful for how do I solve problems when they go on, right? The nice thing we do have is that Kubernetes is kind of becoming the operating system for the cloud. As you develop applications, you're going to have some you want to run on-prem, you're going to have some you want to run in the cloud, you're going to want to be able to burst different ways. And Kubernetes is really enabling that standard so you can write an application in one particular way and have it be portable to multiple locations, multiple clouds, multiple instances. Along with that, of course, each one of these clouds brings different services, be that an on-prem cloud you're running yourself, or it could be, again, one of the major vendors out there. And so the view Sysdig takes, the view a lot of us in the industry take, is that we need to be scalable and we need to be able to work with anybody. So finding a way to give good information and good data across all these things is a really difficult problem. Then you start layering security on top of that and having to deal with the way different specs, different vendors, different people work with security in mind. It becomes even more complex. And that really leads us into what are those risks, right? What do you have to even care about when you're doing applications in a cloud native way? Workload wise, it's all about runtime threats, vulnerabilities in the static images, auditing stuff. It's really kind of that static approach to what's going on and knowing how to deal with things as they come your way. On the infra side, it gets incredibly complex, incredibly fast. Again, like I said, people start doing these things across different clouds, and every cloud implements something a little bit differently, right? Maybe everybody supports an object store, but the way they implement that object store is different between each one. The way they handle accounts changes, the way they do permissioning sets in user groups is a little bit different. And so all that stuff becomes really complex. And so then how do you even know what you've configured, right? If your DevOps team is a AWS oriented team, and now you're spinning up a new setup in GCP or a new setup on-prem with Ezmeral, how do they accomplish the same feat that they did in AWS and have that same level of security knowledge and trust in their configuration? It's really difficult, right? You can't be siloed. Doing these things in little myopic views does not work very well, considering how dynamic the nature is of the cloud native world. So with that, it really kind of leaves you blind. As you start approaching things in containers and Kubernetes in the cloud, it's very difficult to get information out of that setup and knowing what's going on. When you do get events, when you do find security things or you do find operational things, not having context makes it really difficult to understand what's going on. If you think about that in, again, context of Kubernetes, containers can be spun up anywhere at whim, anywhere there's resource available. And so if a security event comes out, say, somebody opens up a shell in a container or inside of a pod or something like that, not necessarily knowing exactly where that pod is running, well, that's a problem. So being able to get context in this dynamic world is amazingly critical. And then along with that, containers have a pretty short lifespan. I don't know if you guys follow it or not, but Sysdig puts out a container usage report every year. And one of the most interesting statistics that we found from that is that the average lifespan of a container is less than 5 minutes, right? Over half of all containers go away in less than 5 minutes. And when a container goes away, everything that it was goes away with it. So being able to have an audible trail, being able to know what happened when that container was running, that's a key aspect of being able to properly secure your environment. And so again, as we start looking through, how do you do security? How do you do visibility? It's all about the context. And so when we start looking through an example, if we had a problem where someone reads the shadow file, how do you know where it occurred, right? What container, what node, whatever it is, you have to collect all the metadata that surrounds you, the cloud environment data, the Kubernetes and container data, so you can then be able to see, okay, well, somebody exec into a pod, that person was Loris, and they ran a password brute force script against the shadow file. And so being able to figure out these three things, while it seems trivial, when you do it in the cloud native approach, this becomes really hard. And this is something our customers struggle with, both yours and ours, every single day. Same goes for how they do observability, right? When you start looking at metrics, if you want to know just the health of an HTTP endpoint, again, you have to be able to know exactly where it came from. Otherwise, the data you get isn't really very, very valuable. You don't necessarily know how to fix that. And so there's lots of things going on here that become incredibly difficult once you introduce kind of the dynamic nature we're looking at. And so you really need to have a driving force to do this in a cloud native way up front. So a lot of these are all quotes from our customers who chose Sysdig. And really, they all kind of have the same thing in common, is that they want to be able to manage this stuff in a way that makes sense to them, but do it in a cloud native approach, right? I won't bother reading all the quotes, but up here on the screen so you can go back and check them out. But it's a theme that we see over and over and over again with the customer base who are running applications this way. What's happened to fill this gap, to fill this need, is that we have found that the security stack and the observability stack for cloud native is really going open source. So if you look at things that surround Kubernetes and surround the container ecosystem, you're getting things like OPA and Falco, Anchor Engine, Guard Duty, right? All these different tools are showing up to help solve these problems, and they're showing up in the open source space. The wonderful thing is that means they're agnostic. The terrible thing means that's really hard to configure all those different tools and make them work together. And so the Sysdig approach has really been to embrace the open source community, contribute back to the open source community, and be able to actually do these things in a way that aligns with the CNCF, aligns with the way our customers want to approach observability, security, and running this stack. And so if you look here, this is our founder here at Sysdig. This is Loris Dejwani. He is the creator of Falco and Sysdig. Falco is something that Sysdig wrote early on and then gave away to the CNCF to let the community really embrace it and take it and evolve it in a way that made sense for how folks wanted to run security for their applications. We contribute back to it, obviously. We still have a lot of involvement in helping make sure it's evolving and iterating, but it's no longer a product that Sysdig owns, right? We gave it to the community and we've embraced it as the way we do runtime security here and evolve with it as the community pushes it. Along with that, we are definitely a DevOps oriented company. We are very much an engineering company, much like HPE. And that is what we care about first and foremost. And so we try to be fairly agnostic, work with everybody. But at the end of the day, we're just a bunch of nerds who like to build stuff and build cool things that go fast. And that has really been helpful for us in terms of how our customers perceive and use us, right? Like this is kind of the little group of folks who we have today. A lot of these people really appreciate the open source approach we take. mistake, because we firmly believe at Sysdig that, while we really appreciate our product and we like what we built, we don't want to lock people into a particular way of doing something, right? If they start with Sysdig, that's wonderful. If they decide to move on to somebody else, that's great, or do it themselves, wonderful, right? There's no problem with that. But we want to be able to make sure they take the stuff they built with Sysdig and it's portable to whatever their journey is, right? So that's why if they do stuff in Falco and build custom rules, they can take those rules with them as they proceed down their path, right? They're not stuck into Sysdig, they're not locked into us. We just want to help support them in a way that makes sense and enable them to use technology they're used to, like Prometheus, like this, open source scanning engines, like Falco, things like that. And really what it comes down to us is really embracing that notion of how do you deal with threats and detecting stuff in that cloud native environment, right? And so we are looking at the cloud, we're looking at stuff across the entire cloud configuration, we're looking at the workloads, and we're trying to unify all that into one data source. The way we typically do that is by ingesting a ridiculous amount of metadata, so that we could interrelate things happening across the stacks. Be that on-prem in something like Ezmeral, be that in the cloud on EKS or whatever that might be. We're trying to interrelate all those things together so that you actually know when things happen, where they happened at. We've extended that up further. And so one of the things we were really proud of is that we're able to extend the Falco engine to be able to intercept information from other locations, right? When Falco first started, it was all about looking at system calls and knowing what was happening inside of the container, inside of the nodes running workloads, and being able to get really deep forensics information about activity happening in your environment. That was a wonderful thing, but we found out that we can really do more with that. And so we built out some functionality around Falco that lets us actually use the Falco syntax, the Falco rule engine, to evaluate other things. So in the Sysdig solution, Falco can also do evaluations against the Kubernetes audit API. So as you create new events or new namespaces, modify config maps, all those are actionable items that Falco can then ingest and alert and notify on conditions happening across the Kubernetes stack. Once we did that work, we realized, well, that's wonderful, but now we can even take that further and we can intercept logs that come from the cloud providers or come from other sources around us. And so Sysdig made the journey into CSPM and being able to actually ingest data coming from AWS logging, Google logging, Azure logging, and be able to take those events and turn them into actionable real-time audit events, leveraging the Falco engine. And then we also integrated things like Cloud Custodians to do static analysis of the cloud configuration. And so really what's happening here is we're on this journey to give people one tool to analyze everything across their cloud native stack and interrelate all those things together. It'll make a little more sense in the demo when you see that, but just kind of know that's one of the areas we're developing really heavily on right now. When we go down to the roots of how Sysdig works, was there a question? Okay, cool. It really gets deep into what goes on the nodes itself. So the analogy I like to draw here is that Sysdig is very similar to something like Wireshark. Wireshark instrumented packets, used packets to get really interesting forensics and monitoring data out of switches. And Sysdig does a very similar thing, but for the nodes themselves. So when Sysdig gets installed across your entire environment, we instrument the Linux kernel, and then we grab data from the kernel about actions happening, host metrics, network statistics, Prometheus and StatsD metrics, security events. All those things come from our agent, intercepted at the kernel level, and get pushed up into the cloud that we then do all the analysis on. A lot of the reason for that is, if you know the name Loris Dejwani, it's because he's the co-creator of Wireshark. So it was really about how do we take a industry standard tool and use a similar concept with the cloud native world, right? In cloud native, you can't plug into a switch. Traffic is on the software level. It's going intra-host, right? It's never actually going through a NIC of any sort. So how do you do a instrumentation in a central way when the compute layer is effectively distributed? And so the Sysdig approach is to use the kernel. It's very, very cool technology. I highly encourage you all to look it up. It's something we can nerd out on for quite some time. It's very, very cool stuff. So if you remember nothing else about Sysdig, basically remember that Sysdig is to Kubernetes as Wireshark is to networks. If you keep that in mind, you'll always know how Sysdig works effectively. So with that, I'm going to go into the demo and show the cool, fun stuff.
Hey, Alex, this is Chris Purcell. I worked with you in those Robert Christensen interviews you did for Discover. I have a question for you. Not saying go back in your slides, but this is all really, really interesting stuff for me. My question though is, you kind of indicated that everything that Sysdig is doing is open source. You indicated that, hey, we donated essentially Falco back into CNCF. So if Sysdig is everything open source and you're donating your projects back into a CNCF type organization, how do you generate revenue?
That is a great question. And the way we generate revenue is by doing all of the hard work for our customers, right? So when I say Sysdig is open source and a lot of stuff we do is open source, a good way to look at it is open core, right? All of the components we use, like Prometheus, like the Sysdig agent, Falco, guard duty, right? All of those things, or cloud custodian, I should say, all those things are open source projects that you have to wire together yourself. When you leverage Sysdig, we do a lot of the workflow for you. So all you do is deploy the agent and everything else comes, right? The backend we run can be able to handle 100 million metrics of ingest per minute. That's not an easy thing to do, right? If anybody's tried to build an observability platform, that's really hard. And so what they get with Sysdig is a turnkey approach where you install it and everything comes out of the box. Policies, configurations, compliance reports, all the things that you have to build yourself and have to make sure are following different specifications, you get that as a customer of Sysdig.
All right, so just help me better understand it then. So you're doing almost like providing a service for setup and running?
We're providing a service for a platform, right? It's like the easy button. If you want to do observability in Kubernetes today, you're going to probably go set up InfluxDB. You're going to go set up a Prometheus server. You're going to go instrument all of your applications with node exporters. You're going to aggregate that data back into one central location. You're going to start building queries and dashboards to visualize those things. That's months, if not years of evolving work.
I get it. Yeah, you're good. All right, so I get it. Good. Yep, that's great. Thanks, Alex.
Yeah, no problem. So here what we're looking at is Sysdig Monitor. This is the observability tool. And we're actually looking at your guys' dev cloud cluster running on Ezmeral. This page here is the overview spot. It's where I typically start when I'm looking at applications or how to figure out what's going on. And really what it's telling us is that we have a number of events coming out of this Kubernetes cluster. All of our nodes are up and running. All of the pods we expect to run are running, and our memory and CPU footprint looks pretty decent. And so I know from a high level view that everything looks decently healthy from a high level perspective, but I can see that there are a number of events coming out of that cluster, right? We have pods being created, containers being killed off. We do see some stuff about replica set scalings and even things around container unhealthy events. If I highlight one of those events, it starts telling me exactly where it's coming from, right? What it's saying is that the liveness probe on this container has failed. And where did it fail at? You know, what host name, what IP addresses, MAC address, what cluster name, namespace, daemon set. Basically, we can see in the kube system, we had a container go unhealthy. And then if you note, we had a replica scaling event happen right after, right? And so basically just Kubernetes going through its operations, the canal daemon set probably got expanded and pod got created and stuff went on. And so it kind of gives us a quick view of what happens, why it potentially happened, and then I can actually dive into my workloads and see if there's something that's more relevant to me. So if I want to hit this little arrow, I can come into my namespaces, see all my applications that I'm running inside this cluster, and be able to look and see what's happening from a memory perspective, a CPU perspective, what's going on there. So one of the fun things we can see here is the kube system. It's certainly using significantly more memory than its requests out there for. So maybe there's some right sizing we can do in this Ezmeral cluster to make sure the kube system is getting all of the resource it wants and it's not being tightened up. We can see that likely based off of the load on the system, even though that's over spec, it's not a big deal. We're not getting any pod restarts. It's just kind of one of those things that as we scaled up this cluster, we'd want to make sure that this particular component stays healthy. And so we'd want to maybe do some work on that limit, make sure that we're giving it enough memory and CPU to do its job. If we keep kind of looking down, same thing goes for Cert Manager, which is another Kubernetes component. We also installed a little thing on here called the voting application. We did that last night, I believe. So if we keep on going down, we will see the vote one down here. And you can note that it has had a few pod restarts. That's where we see that line going up and down. But overall, it looks pretty okay. So if we highlight the vote namespace, we'll scope our events just to this particular one. And again, we can see container unhealthy events. We can see pods being created, and that's where we're seeing those pod restarts. And if we go highlight one of those, basically it's telling us again that probe has failed. And so that would be inside of different parts of the application itself, and we can investigate that a little bit further if we'd like. So to do that, again, we just hit that arrow and we go into things like workloads, and it'll do the exact same thing we just did before, scoped into just that namespace. So we can look through our different pods that are running in there, and we can see pretty quickly that the result pod is going through that restart cycle. So everything else looks pretty okay, but this one pod in particular is having the problems. And so we go through, look at events, see why, see what's going on, and try to figure out what might be causing that. In this case, it's just the voter, right? It's just pushing data through back and forth, and it's probably just spinning up the new workload as time goes on. Most likely not a big deal. The voting app's a pretty basic demonstration of a Kubernetes application. But if we wanted to, we could take this and look further into it, investigate other things across that cluster. The way we do that is to go into this Explore view, and it lets us really start walking through our data in interesting ways. So I can visualize all of my stuff based off metadata in Sysdig. I had mentioned before we pull all of that information. So I can create custom groupings. I can interrelate cloud data to stuff coming across the worker nodes themselves. In this case, I've chosen one called deployments. This lets us look at our infrastructure, see our cluster, and then see all of our namespaces in that cluster. All right, now I've highlighted the voting app, so I'm scoping my view here on the right just to this voting application itself. Right now, I've got a view called top processes up. And so really, we're just showing the processes that are running inside of this namespace. If I wanted to, I could go highlight a deployment like the DB and see just the stuff running inside the DB pod, which in this case is just Postgres, which is good, right? We don't want a bunch of processes per pod. But it lets me be able to visualize all that stuff and see it pretty quickly. The reason why stuff like this matters is one of our customers has a distroless environment. They don't have shells on their containers, but their auditor wanted them to be able to reproduce artifacts about stuff that's been running on their containers for the last 2 weeks. That's pretty hard to do when you don't have a shell, right? They were kind of racking their brains on what they were going to do to get that data out. And then they realized that Sysdig captures all that information for them. So they came in here, went to the application subject to the audit, pulled up the last 2 weeks of data on processes running, and produced an artifact pretty quickly for their auditors. So lots of use cases around stuff like this that might not seem, at the top of minds, but different new and novel ways to leverage the data that we do pull. Along with the process view, we can also go into things like the network view, pull up connections tables, and I can actually see live connections coming out of this namespace or out of a particular pod around, where they're communicating at, what the service is, what ports being opened up, how much traffic they're sending. It lets me kind of get deep into how much data is coming out of the various endpoints. Along with that, I can also visualize the way these connections look in the monitor product. So I can hit this thing called network traffic or response times, and I can start honing in on the different components. So right now I'm looking at the cluster. If I expand the cluster, I can get into the namespace here. I can pop open the namespace and get to the various pods or deployments, I should say, get into the pods and scope myself all the way down to the processes inside of those containers. And so lets me actually be able to visualize latency as it exists through an application. So as you can imagine, if you're running a real Kubernetes app and you've got it distributed across your cluster, you might have 10, 15, 30 nodes in that cluster, and these containers are going to be running anywhere there's a resource available, right? So as you're trying to figure out when there's a latency problem or users are reporting stuff isn't working quite right, how do you figure out what pod is affected or what process is causing the grief? A visualization like this lets you very quickly zone in on just the application you care about, regardless of where it's running and the connections it's building out, and looking for latency problems, right? This black line here is showing me latency between two pods. So maybe this would be on one node, this is on a different node, and maybe my problem is the network between those two locations, right? Conversely, if I'm seeing stuff intra-node, I'll be able to see what the processes look like inside of the actual process itself, when that latency looks like. So it gives me a very quick way to visualize an application and diagnose where my problem is coming from to go into further troubleshooting. I'll kind of leave it at that. I'm not going to belabor the point. There's lots of other really cool stuff here in Sysdig, especially around Prometheus and the PromQL library, where we can be able to give you a bunch of static queries you can run or build different ones itself that you want to be able to visualize stuff with PromQL. Lots of really cool stuff here. Happy to be able to talk about this at a later point in time, but just know there's lots of really fun things around this that you can do inside of Sysdig as well. So with that said, I'm going to pivot over to the Sysdig Secure product. So this is the other side of the coin with Sysdig. When you install the agent across your nodes, we use one data source to get all this information for both observability and security. So you don't have to install a bunch of different things. You don't have to instrument your containers. You don't have to put a bunch of sidecars in place. You just put in the Sysdig daemon set and all the data starts coming out. What we're looking at right now is kind of our bubble view of events happening inside your cluster. So again, we are looking at the Ezmeral cluster that is in the dev environment here. And we can see there's a number of events coming out that we're just picking up out of the box. So things like running untrusted shells, or the Docker client is running inside of a container. So Docker and Docker is going on. If I highlight that, I can see we got a bunch of them. And I can see that they're coming from a bunch of different nodes. And we're basically doing a command line kube control command that is doing some work there off of Ezmeral. I'm honestly not sure what this is. This is something that's probably specific to you all. And if this were something that we're okay with, that we know this is standard operations, we don't want to see all this stuff, you can see up here that we open up a button that says 5 tunable exceptions. And so we look for events that are happening over and over and over again that might be a bunch of white noise, and make it really easy to say, well, this event that's happening that we're seeing in here, like the Docker client executed in a container, we're okay with this, right? This is standard operation for our orchestrator or what we're doing. I'm going to go ahead and check that, and I'm going to apply an exception to this rule. So that will then filter out these 546 events, right? We don't care about them. They're not a big deal. And so we're going to say that's okay, and we'll automatically tune those out so that we get rid of that noise. This bubble view makes it be really easy to see what types of things are causing a lot of information, or you might be kind of overwhelming with where you miss something. So what I mean by that is you can see we have, hundreds of events of both the Docker and Docker and running untrusted shells. We only have 2 of this redirect of standard in, standard out inside of a network, or a container in a network. And so if I go highlight that, I can actually see just that one little event. It made it pop up much easier, whereas if I go to an events feed, it's really hard to catch just those 2 events, right? Because we have so much fluff showing up in there. So that's why we built this bubble view, to make it be much easier to discern things that are happening that we might miss otherwise. So along with this view, this visualization of stuff happening across the environment, a lot of our customers start here in image scanning. And this is really about image health, right? We want to build out policies, and we want to make sure that people are following spec, that as they are developing images, developing applications, they are doing those in a way that meets security spec. So you have a number out of the box. In this environment, there are just a few. There's also a couple others around FedRAMP, so NIST 853, as well as SOC 2. But at the end of the day, they all give you policies that are prepackaged and pre-built for you that meet different specs. So this spec here is about 800 to 190, and basically it's kind of a good guideline of misconfiguration you should look for in containers. So as you're building applications, you can basically ensure your developers have ownership of that security notion, and they are going through and ensuring things like there are no high or greater CVEs for either OS or non-OS packages. That port 22 isn't open inside the Docker file, right? It's not configured to accept SSH connections. That you're not storing things like AWS access key on the file system somewhere, or you're not storing an environment variable of password, right? These are all things you shouldn't do, especially in production applications. And so it's a quick and easy way to get alerts and data back about my configuration of my app, especially if I'm pulling down things that are coming off of, Docker Hub based images or something like that. It lets me do kind of those baseline checks and ensure at least the minimum is being done. If I'm happy with this and want to add a couple things to it, I can actually go and duplicate policies. I can edit all these various gates that we've set up. I can put in stop actions if I want to. So if I'm really concerned about developers leaving private keys on images, I can go turn that into a stop action, and I can fail a build if we find one. Along with that, I can define new gates. So one of them I like to point out is that when Sysdig does a analysis of an image, we look at it holistically. And so I can even interrogate things like license files. The reason I bring it up is that there are certain pieces of software, right? You're not supposed to redistribute without a license. And so let's say you've got a Java-based application and you are not licensed to redistribute the Oracle JDK. Well, we can go in and we can find the Oracle license. And if we find that, we can go ahead and stop the build, right? The last thing we want is an audit to come through and have to pay a bunch of money for something we didn't realize we were doing. So it allows you to use the image analysis in different ways that fit different needs across your environment. All these policies can be evaluated in different ways. So I talked mostly about the build time phase. So when you're doing your CI/CD pipeline, all sorts of ways to integrate this with your process, regardless of what you're using. But we also do this at runtime. And so we look at our images as they're running across our clusters, and we can go and see how those are aging out, how those are changing. So you can see here's the vote namespace. I've got one passing for Redis. I've got some other ones failing. If I go look at something like, I don't know, the voting aspect of it, the voter component, I can see that we have a number of stop actions and a couple warns. If I go highlight that policy, it'll show us why we have those actions showing up. And effectively, they're all high vulnerabilities inside of this image itself. If I want to, I can go look at them by the OS. I can see those same highs. I can see what package is affected, what the fix is when it's available, and be able to generate a listing of these things. So this is really useful to say, well, I've got running applications. I've got dev teams that need to manage these and take care of them. They should be staying on top of this so I can go pull reports for them. But as ops people, we don't want to actually have to do this manually all the time. And so there's a nice feature inside of Sysdig called schedule reports that allows us to actually go in and build out different reporting functionality that will automate for us. And the cool thing again about Sysdig is we always tag this stuff with metadata. And so I can say, I want to go look for any vulnerability that is running in my existing environment inside of a cluster, inside of a namespace, inside of whatever it might be. And I want to go look for various conditions. So right now, this report is going to pull for every vulnerability inside of the Kubernetes cluster, K8 cluster 1. And we're going to look for any severity that is, let's say, greater than or equal to high. So if I hit that preview button, let's select a different cluster because now it's cluster 2 and redo that. We'll pull up all the data that's coming from anything high or greater running inside of our current cluster. I could then take this, turn it into a report that goes off on an email, pops out a JSON or a CSV file about whatever is vulnerable. So if I have key application owners, I can effectively scope myself just to their application, look for things that match the condition that I want. So it could be severities of packages, it could be CVSS scores, whatever I want to key off of. And I can give them an automated report that comes out weekly, daily, monthly, whatever I want, to say you should be taking care of this application and here's your new vulnerabilities. So they can push this out any number of ways, right? We're using notification channels right now. This could be webhooks. This could be stuff that goes into ServiceNow. Whatever their remediation workflow is, we can dump this data into there and they can kick off whatever their cycle looks like to update their applications and keep them vulnerability free, or at least aware of what those vulnerabilities are and be able to write up if that's okay. So hopefully all that makes sense. Lots of really fun stuff here in the policy engine. The last thing I will talk about in scanning is Sysdig does have an emission controller that we've written. And what this really is about is kind of that third level of security of the images. We're able to deploy a controller that dictates what can be deployed where inside of your environment. So if you have some clusters that are PCI compliant, others that are SOC 2, subject to SOC 2, maybe some are subject to FedRAMP, you have different controls you need based off production dev, whatever the use case is, you can deploy an emission controller to that cluster, and then you can dictate based off policy what can come in. So this is kind of a combination of saying, well, I need to pass a particular scanning policy like we saw before. And in scope of a particular cluster, I want to make sure that that always passes. Or, if it doesn't pass, that's okay because it's dev, but I do want to make sure that all those images are always scanned, right? So if they haven't been evaluated in the last 5 days, let's make sure that happens. I can also say that, well, I don't want any unscanned images running in my environment in production because that's just not okay. So I can either reject those or I can reject them and force a scan on that image. So really the emission controller is about dictating what can be deployed where and meet your regulatory or compliance needs based off that. The other area that's pretty fun here in Sysdig is we've done a lot of work around compliance. A lot of our customers really struggle with how do you do compliance in a cloud native way. And that's what we're trying to solve with this feature. And it's really about looking at your workloads and your host configuration, node configuration to make sure you're meeting spec with the various entities that are out there. So if I go look at something like the NIST 800-190 check here, we can go scope ourselves into a particular cluster. So we'll say K8's cluster 2, and I can go look through the controls that pertain to stuff that is subject in containers and Kubernetes in the cloud native world. And I can look for what I need to do to meet that regulatory need. So we give you artifacts about what the check is, how we address a particular check, and how you should remediate that particular one. So it's a really easy way to go through a cluster and make sure I'm meeting kind of the base level configuration that I need to meet whatever an auditor is going to look for that particular spec. Along with that, we also pull in the benchmark world. And so if we go look here, we can look at benchmarks against our nodes for CIS for Linux, the CIS benchmark for Kubernetes or for Docker itself, and make sure that we're doing kind of the minimum we need to do to harden our nodes per the CIS specifications. So again, this is really useful for deploying out nodes that are going to go in production and making sure those nodes have been locked down from the OS, the runtime, and the orchestrator levels. And again, just like before, if there is a misconfiguration or something going on, we give you tooltips on how to correct those and how to remediate those particular things. Let's see, a couple more things, and I'll open it up to questions for everybody from the audience. One of the areas around Sysdig that's kind of the bread and butter is really around our runtime detections and forensics. So we talked a lot about Falco earlier, and that's really what these policies are all about. In Sysdig, these are all things that come out of the box. So again, going back to Chris's question about, why would you buy Sysdig? This is why you buy it, right? The compliance world, having all these policies built out, and then this runtime library of stuff that lets you detect all sorts of things happening across your environment and being able to react to those as appropriate. So this will handle anything like opening up shells and containers. It could be unexpected UDP traffic on port 53. So someone trying to hide something masquerading as DNS. It could be stuff coming in from audit logging inside of Kubernetes or CloudTrail and AWS. All these things have been linked back to various specs and frameworks for whatever they might relate to, and let you kind of sort and filter through rules pretty easily. Obviously, Sysdig has spent a lot of time building a ton of rules. So how do you make them useful and actionable out of the box? You collect rules into policies. And so we built a number of these things, again, for our customers to be able to easily take an instrument in their environment, and they are effectively collections of those rules that you can then modify for your own use cases. So like here, we have suspicious K8's activity. If I go look at this rule or this policy, it's a collection of just 4 rules that's looking for stuff that's just a little bit suspect that inside of Kubernetes that probably shouldn't be happening in a production environment at the very least. So it lets me come in and scope myself. So again, everything in Sysdig is about metadata. I can pull in any of the data that I have across my environment. So it could be custom tags, it could be Kubernetes tags, Docker tags, it could be cloud tags, and it lets me be able to scope this stuff in a way that auto-inherits. So if I wanted to make sure that there was no suspicious K8's activity, but I only cared about my production clusters, I can say that anything inside of K8's cluster 2 is subject to this rule set. The nice thing here is that, if I've got applications that are subject to PCI, but they're going to be running in multiple different clusters or different namespaces, I could make a custom tag that's, Kubernetes.blah, Kubernetes.tag is PCI. And then this rule will auto-inherit anywhere that tag on the container exists. So what we tell folks is that as part of your CI/CD pipeline, tag up your containers to what they need to have on it, and then you can auto build out rule sets and policy sets that inherit against those containers regardless of where they run at. So super nice, super cool stuff you can do here. Allows you to be able to easily import, export rules, do different things inside of that, be able to do various different things. Along with that, we also can take various actions. So you can see things down here like kill, stop, or pause. So if someone were to launch a privileged container in production, maybe we want to say that that's not okay unless it's been whitelisted. And so we can then go ahead and do a stop or kill command against that container every time it tries to spin up. So able to react to events as they show up. You're not stuck with just kind of static alerting, lets you have a level of reactivity to it. And then we can also do things like capture files, where we can store all of the content from a particular node into an outside file for interrogation at a later date. Really all about forensics down here in reaction, something that we do very, very well, and a lot of our customers quite like. So what does that actually look like? If I go to my events view here, and I look at all of my different things, I can see, well, I've got a bunch of that suspicious container activity, or I'm having a bunch of things happen here that I want to investigate further. So I could go highlight one of those. Again, it'll show us all sorts of data about where it came from. If I go to some other ones like, let's see, go down here, let's go to unexpected spawn process. I can see again where it came from, cluster, namespace, image, repositories, all those types of things. I also have this activity audit button. Because a shell was opened up, we started to actually capture all of the things going on inside of that shell while it was open. So it lets me quickly be able to go through and see things, see what happens. I can go to my investigate view, and I can actually start seeing commands that were ran in those various scopes. So I can go through and quickly audit what commands were ran on what location, what was that command, when that command was ran, what UID was it, what PID or parent PID was it, what other processes did that parent spawn. I can easily filter on and see that as well. In this case, it was just this one time, but it lets me be able to quickly go through that and get those details. Where this becomes really powerful is when people open up shells inside of my container or doing stuff in production that maybe they shouldn't be doing. I now have a running record of all those things, regardless if that container is alive or dead, right? So we mentioned earlier that the lifespan of a container on average is less than 5 minutes. This ensures that if someone went into that container and did something, I know exactly what happened. I know exactly what they touched. I know what was changed. I have a running record of all of that information. Let's see here. Last thing I'm going to point out, and then I'll be done talking, is here in the network tab. This is implementing a thing called Kubernetes network security policy. And so it allows us to look at an application, visualize the way traffic is going through, a lot like we saw back in the monitor product, but it pulls up a bunch of tags around the application as well and lets us see things like port communication and all that in one clean view. Two use cases here are one, we can just see how it works, and then we can be able to dictate how stuff communicates if we want. So if we come down here to this Spark service and go to topology, we will note that there is communication coming in and out of that namespace to external IP addresses. I don't know if we're okay with that. Again, this isn't my cluster, but I can easily see that I've got traffic coming in and out that's not Kubernetes-based traffic. So if I want to, like right now, the default would be that that's not allowed, right? We don't want traffic coming outside of this namespace. So you can see those lines are red. If I wanted to say, well, that's okay, and it's okay for traffic to come in, I can come into the ingress and I can then whitelist that, check in this box, or conversely, if I'm okay with it communicating out, I can again go whitelist those. And then I could then generate a policy that says that traffic's okay. So I'm going to go ahead and say it's fine. And I'm going to generate that policy and apply it to my environment. So if I come back to egress, if I hit those buttons there, come back to policy, you'll see that now my egress is saying that those two things are okay. So I then cut and paste this, apply it to my Kubernetes configuration, and then it ensures that the way this communication looks, where these two things are now allowed, would be applied to this namespace. So easy ways to visualize how traffic is flowing. I can then say if it's okay or not okay, and build out configurations for that. And I can even generate, artifacts or PDFs on how this application flows. Typically needed for auditing purposes and compliance purposes. So really nice to have a way just to generate artifacts about the way an application flows, what endpoint it's communicating to, what port it's communicating on. All that data is here. So with that, I'm going to stop. I'll answer any questions y'all got, and happy to go from there.
Thank you, Alex. That was a great demonstration. We can open up to questions. We have a decent crowd, so let's start asking questions.
Hey, Alex, this is Kawhi. Great demo.
Hey, Kawhi, thank you.
Hey, just a quick question. So there was a lot of recent, high-level publicity or profiles around some of these security attacks, right? The Colonial pipelines, or these ransomware, Kaseya, and SolarWinds. So I don't think they're container related, but let's say if these things happens to be the container versions, so how would something like a Sysdig deal with something like these type of attacks?
Yeah, there's a couple different things that we do that pertains to that. The SolarWinds one specifically, that was an interesting one because it was really an attack based on cloud lateral movement. So in that case, they had an event occur in a adjacent region, right? That was kind of an unused, neglected region. And then from there, they pivoted inside the cloud to a different region that actually mattered. That's a really difficult attack to detect. And that's where Sysdig comes into play for our CSPM tooling. You don't see it in this demo because this is a Ezmeral cluster internal to your guys' environment. But if you can imagine this bubble view, but instead of having things like containers or clusters up here, you would have cloud accounts, right? And cloud environments and regions inside of those environments. Again, you're able to bubble up events coming from those different regions very, very easily in this view and be able to detect when things are happening in spots you didn't expect. So if you run in US East 1 and you had something happen in AP South, you would see an event in AP South and say, well, hey, why am I seeing one little bubble in a region I don't use? What happened there? And being able to visualize those things very easily and doing it in real time. And so that's kind of where we're approaching attacks like the SolarWinds one to help make sure that when events happen at the cloud level, you're able to see those very quickly and take action on them before it becomes a problem. Once they do come in, obviously they're going to try to get to resources, right? They're going to start doing stuff on nodes, doing stuff inside of containers or whatever it might be. There's a composite view that we have in Sysdig as well, that again, you're not going to see anything in this environment, but what it does is it relates cloud user activity and cloud activity to container and Kubernetes and node activity. So that if someone comes into a region, spins up an EC2 instance, uses that to try to go somewhere else, you see all of that data and all the stuff they're running across those nodes, all the way down to the system call inside of the container level. And that's where all those rules we were looking at earlier come into play. And it makes things like, crypto mining attacks or ransomware attacks much, much easier to find because they're happening, they might be generating a bunch of noise to hide the stuff that's actually going on. And we're making all that stuff very easy to visualize and very easy to catch. Does that answer your question?
All right, thanks.
So going back to Chris's earlier, this is why people buy Sysdig, right? It's all open source oriented, but these workflows, being able to do this stuff visually, doing these things easily, that's the hard part, right? That's what Sysdig's an expert at doing, and that's why customers come to us and buy our products. It also helps that we're a DevOps shop ourselves and use our own tools. And so we're running into these problems every day as well, right? This is stuff that we have to solve for our own needs. And so then we push out stuff that we figure out to our customers too.
Thanks, Kawai, and thanks, Alexander. Any other questions? We've got a few minutes left.
Cool. Well, if anything comes up and you want to talk one-on-one, you can easily hit me up at alex@sysdig.com. I was lucky enough to get the alias of just my first name. So don't hesitate. Don't hide. I'm happy to answer anything that all might come up that you don't want to bring up in a group forum. So.
Thank you, Alex. That was a great session. I will launch the poll for everyone. Please provide your feedback on this type of sessions. It takes only a few seconds to answer the 3 questions. And that gives us some feedback on what kind of sessions to provide for the future Dev Talks. So thanks, Alex, again, and thanks everyone for joining. We'll see you in 2 weeks.